need a jingle. Nobody's submitted a jingle yet, so I'll have to come up with one next week when I'm not so busy. Hello, and welcome to Practicalli, and welcome to my very messy hair today. Thank you very much for joining me on this slightly chilly Saturday morning. As you can see, I've been quite busy coding and not busy shaving. So hopefully we'll show you something interesting. I didn't quite get everything working I wanted to, but we've made some progress. So today we're going to continue working on the COVID-19 dashboard I was working on. It's quite interesting because if we go to the gov.uk website, the dashboard that was there has now changed. So they've completely changed the dashboard and they've changed the structure of the data. So that means that my stuff doesn't work anymore, or the dashboard doesn't work anymore with the new data that they've got. I've still got the old data, so I can still generate a dashboard. We have the dashboard there, just as a reminder. So if we go to yes, dashboard. So I've got the dashboard. Oh, I haven't used this one for a while. Oh, I haven't got the totals there. Okay. Well, see the previous video for the dashboard, but what we're going to focus on this week is the trying to get a geographical view. And so what I've done is refactor the extraction and transformation of the data. So I've just downloaded the cases data from this CVS file. So it's just and it's actually a CVS file. It's not a Word or Excel spreadsheet. So it's a little bit easier to work with. Although, yeah, there's not really much difference between CSV and the Excel spreadsheet if you're using the right libraries. It just means I don't need to use the docxlj library to pull things in. I could just work with the CSV, and this time I've used the semantic CSV library as well to do to basically create a nice map out of the CVS data we've got. So I'm going to try and there we go. This is the kind of the dash. There's a picture of the dashboard on there. So that's what we got so far. But we didn't have a geographical map, and I'm going to try and add that with a range of data. And there's a slight bug, so I haven't quite got it working, but I can make it look like it works. So the power of it. So there's a bit of smoke and mirrors this week, but hopefully I will fix the slight bug I've got. Okay, so that's what we're going to do. So just a reminder, if you need to get in touch or you want to see any of the other previous videos, then they're all on YouTube. I've also organized them into different playlists as well, so that make it easier to find particular things. If you want foreclosure, there's a foreclosure playlist on there as well. So if you just go to the Practicalli channel, and then there's playlists here that kind of help you find the particular videos you want to. So there's Code Wars, there's like stuff I'm working on web apps, there's some Spacemacs, foreclosure, some of the new things I'm doing around the Clojure CLI tools are there as well, and obviously the study group's got all of the 70 hours worth of videos on there to keep you busy while you may not be going outside. And I'm putting these specific ones I'm doing on Oz and data science in the data science playlist. And there's books I'm working on, so I've been doing a lot of updates in Spacemacs. I'm starting to update the Clojure book as well. If you want to reach out to me, you can reach me on the Practicalli channel on the Clojure Slack, and there's a free sign up to do that as well. If you want to keep me motivated, then subscribing to my YouTube videos is an easy thing, doesn't cost you anything. And there's also, if you want to make a financial donation to sponsor me as well, that's always appreciated. And yeah, just feel free to reach out to me and say you like what I'm doing. That's always a good motivator as well, and much appreciated. Okay, let's see what we were doing. Okay, so the data is all on this new this refactored website they've got, and I think one of the reasons they've updated it is because they've clarified that this is coming from kind of like where the information is coming from, essentially. So the daily number of cases is lab confirmed cases, so they actually send everything off to a lab, and that can take up to 24 hours to process stuff. And if you actually go read about the data, there's a section here about like cases over time and with the way the dates are attributed. So the reporting dates were usually kind of a day late because things would get sent to the lab in batches, and then obviously they were only recorded when they were at the lab, so they were kind of like a day or so out. So they're trying to use more accurate data recording of the dates when the actual infections were detected, which is a good sign that they're actually trying to continually improve the data over time as well. So that's quite interesting to read all that. I'm not going to go through everything there, but what it does mean is that we've got new data to work with, CSV data, but it's kind of showing you the same information here as well, although there is probably going to be slight changes. So I haven't quite worked on the zoom. They're using a slightly different approach here to what I'm using. So they're using, looks like they're using OpenStreetMap and this leaflet.js thing. I'm just going to use Vega. I don't have a zoom yet on the Vega thing, but I do have tooltips, and so I can kind of go in. And so the idea is to look at the specific local authorities and map out using shaded, rather than using these big blobs, just use a shaded color here. Although it's at the moment they're all the same value, so it's we'll show it with different values in a moment. Actually, let's see. Where are we? Oops. Oh, here we go. We do that one, and I'll walk through all this code from the start. Just want to show you what it looks like, hopefully, if that's still working. There we go. So you can see my data isn't exactly foolproof, but this is kind of the effect. So here we can see kind of the if there's any hotspots in any particular places. This is not accurate data. I've messed up the data. That's my bug I've got. I'm adding up the cumulative data on each area, which is not what I want to do. And it's not always pulling out the right data because it's pulling out random data. It's not pulling out the data I actually want, so it's a bit of a bug there. But this is kind of the effect I wanted to kind of get. So it shouldn't really have these black spaces. They're off the top of the chart because I'm adding them up incorrectly. Although if I change the scale, I love hacking around, don't we? Let's just do this. Oh no, that's not what I wanted to do. And let's do 4. Is that right? So change the scale, and that should change the. Oh, there we go. Well, that's much better. So that's kind of the effect I'm trying to get to, but with actually using the real data. I'm very close, but we'll see how far we get. Okay. So that paints a picture of where we want to go. Let's see how we actually got there. Let's see, where is it? Oh, there you go. So they changed the data either sometime this week, and so I've gone back to start. So this is kind of like the video from a couple of weeks ago, where the sound was a bit quiet. Apologise for that. I didn't realise that the sound was quite low. So this is a nice recap of what we covered there, at least some of it. So we're doing the ingestion or the extraction of data. So there's usually the term ETL, is extract, transform, and load. So we're kind of doing the extract and transform part of that really with data science. So we've got our our data sets for all our cases. So I've just put that into the resources data, and then it's the where did I put it? Oh, there. Yeah, resources data sets. It's in that one. Yes, I will clean this up a little bit. So we've got this coronavirus sets CVS file just in resources, and then we're just reading that in using this file. So we're going to use the Java, so Clojure Java IO to read in resources. So that reads it from the kind of root of the resources file. So then I've got a folder called datasets and the file name. So this is like so resource does the relative path in the project to the resource directory. So that's so you can treat the resources as root. So when you want to specify a file, then you go into datasets and the file name. So that's what I've done there. Let's get rid of that for now. And then, so I get a handle on the file, then use slurp to read that in. And so we get a nice big string of everything, and then we just convert that. So there's got the CVS, just using the clojure.data.cvs file library to read in the CVS file, and that turns it into a very simple structure. So if we just make sure this is evaluated, boom. We evaluate that, and if I run the inspector, then we can see the type of data that we're actually getting. So this is like kind of a nice abstract view of that result. So this is the results in a lazy sequence, as it says here. We're in a lazy sequence, so basically it's a list of vectors, and then each vector is the the first vector 0 on index 0, so this is the index of the vector. The 0 index is the heading of the CVS file, and all the rest of them are pieces of data. And the interesting thing is that it's all kind of mixed up here. So each piece of data, each row of the CVS file essentially is a recording of how many cases being recorded for a particular day. And some of these are country data. Some of them are region. So country is England, Scotland, Ireland, Wales. Although I think it only has England in this, or I'm only using England for now. And then we've got regions, which are there's like southwest, northeast, kind of the major areas of a particular country. And then there is this upper tier local authority, which is basically the local authority. So you got Barking, Dagenham, Barnsley, Bexley, Heath, Blackburn, Burgley. So all the kind of like the districts, all the kind of where you vote for your local local council. Oh, somebody's mentioning that the GIST isn't working. Oh, let me just try and fix that. It's rocket. No, that's not GIST. Can I type today? Yes, I can. JRockets. There it is. So why wasn't that working? Maybe I didn't copy it incorrectly. So let's see. So this is the code that should work unless YouTube is doing something strange to it. Yeah, that works. I'm not sure why it didn't work before. And so it's about it's all the way down in a long way down. Line 573. So it's actually this link here. Oops. This link here that you want. So that's where we're starting. Thank you for letting me know. So yeah, so we've got the CVS file converted into a nice Clojure data structure, and we're going to focus on just the upper tier local authorities, and we can drill down into these as well. And you can see the contents of this particular vector. So now we're looking at the specific vector from that, and we can see it's got the name of the district. It's got a geographical code, and it's got the type of thing it is, the dates, and kind of the daily values and the cumulative values as well. So it does have all the information we want. It's just in a different format, and it's using lists and vectors, which is okay for simple stuff, but for Vega we really want to convert this into a nice map. And so we want basically we want to take this heading, and we want to convert area name, convert all these entries and these daily entries, replace and turn them into a map, and using the headers as the keys and each of these values as the values associated with the header keys. So that makes each of these lines very self-contained. We don't have to kind of worry about getting the order of the values or maintaining the orders of the values. And using maps is a lot more flexible, because we can just refer to things as keys. Okie dokie. So what have I done? Oh yeah, so I've just done a def here just to read this particular file in, and that gives us the whole data set. And we can filter it by country as well, so we can just get particular values here. So one of the things I want to do is just get England. So obviously, if we want to just do local authorities, then basically I'm just filtering. And I'm using a map. I'm using a set here to as the way to sort of filter out. So we're filtering out everything that is so in this case we get region, in this case we're getting a local authority, and so we're filtering out everything that doesn't match the value that's in the set. So basically saying if there's some value that's in this set that's in the collection of cases, then return it. If it's not an upper tier local authority, then discard it. So filter only returns things that match true, and if you want to return things that match false, we can remove specific things as well. So in this case, if I didn't know what the key was for local authority, I didn't want to type everything in, then in this example I've just used remove, and you can put multiple values in. So this is quite useful little idiom, this, to basically like filter or remove things from a map, or from any collection. So here we're kind of removing everything that's a country and a region, and then what's left is the local authority. But this also keeps the heading as well, because that doesn't have a type. So sum is quite useful. Sum is kind of like is what you would use when you think you want to use contains. but contains works on the it works differently. So on vectors it works on the index, so it works on the keys of a collection, whereas some works on the values of a collection. That's how I think about that. And so rather than have these individual ones, then I just created a little helper function which does the same thing. So pass it a data set and location, and it just filters for me as well. So I did that before I kind of realized I wanted to convert it into a map. But doing it into a map is fairly similar. So what we're doing here is we're still getting the resource, we're still slurping it in, still reading it as a CSV, but then we're actually converting the Clojure data structure, which is a list of vectors, into a map using this semantic CSV library called MapifI. So if I go to the top, you can see I've included a bunch of libraries. So these are external libraries I've included. Well, the JSONist and core. We're going to do some JSON stuff later on. Semantic CSV core. So this is, it gives us our semantic CSV, our MapifI function. I could just do that as a refer MapifI, but because I think I'm only using one function, but this will do for now. And then clojure.data.csv and clojure.java.io. So this is reading in a file. So I like to separate these requirements into what they're actually doing, especially when you start getting a lot of them. If you've just got a couple, it's fine, but as soon as you start doing more of them, it's worthwhile kind of separating them out into different sections. And this also makes refactoring a lot easier as well, because you know which parts you want to refactor and take along with you if you're going to move some code into a different namespace. So that's quite a useful thing to do. Okay, boom, boom. So the MapifI, this. Yeah, as it says, we're just reading in the data, and we're just going to convert it into a map of data stuff here. So now we've got a list of maps around the list of vectors, and it's using the area name. So this is the heading. It's converted that into a key, although it does have a space, which does pop up an interesting dilemma, because it's not putting in a dash in here. So that's something to have a look at in a moment. But it's creating a key value pair in our map for us. So that's closer to what we want for Vega. And then so some people like to write this because it's doing basically a data transformation. We can use the ThreadLast approach as well. So we can do, so we take the file, pass it to resource, and then the result of that is passed to slurp, and then the result of that is passed to CVS, read CVS, or CSV, and then we pass the result of that to MapifI. So these two pieces of code are the same. This is the classic Lisp style, and some people prefer to do this, especially when we're doing transformations. And also when you're doing transducers and things like that, then it kind of because you're doing a sequence of steps, then it kind of makes sense to do actually make that very obvious using a thread first or a thread last function. Well, macro, but yeah. And then I just put that into a function. And so then I can just pass it through. I can pass any just kind of different data sets through there as well. One of the nice things about doing this approach to ThreadLast as well is you can just actually go out and use the reader comment and comment out parts of it. So if something's not quite working, it's quite a nice way to to try and debug something. So what this will do is it'll just pass the data source into resource slurp and read CVS and then return the results. It's going to skip over this last function call because we've just commented it out. And so that works quite nicely in the ThreadLast macro. But it's a bit harder to do that in the kind of the nested list style writing of that. And so then I mentioned that it's using the headers as the keys, and so then when you actually come to try and filter the location using the headers, so we're looking for the area type. This isn't, so you can see by my syntax highlighting that there's something not quite right with this this key. It's not all blue like that. It's got a space in it which doesn't make the key a correct name. So this is treating it two separate names. So this doesn't quite work. We're not quite getting the right values in here. So we're actually just getting a function that's returned. We're not actually getting a result because it's balking on this key name. So we could go in and manually rehash it, but then having a look at the semantic CSV library, then there's this, you can use this keyify false option. And basically what this tells you to do, what tells the MapifI thing to not use the headings as Clojure keys, as keywords. So it should be keywordify, really, I would have thought, to be very explicit, because it's still going to use the headings as keys. It's just not going to convert them into Clojure keywords, which is which is beneficial, because then we could still use a string as a key in a Clojure map. That's still perfectly fine. So we can use, if we do a map, so we can't use a key spaced because that I mean that's okay because it thinks the space is a value, but when we've got key with space and then the value, then that's not a proper definition of a map. But if we use the we can have a key with space if it's a string. Key with space. That's a proper key in a map because it's just a string. We can use a string or a number or pretty much anything legally Clojure syntax we can use as a key, as long as it's unique. So we're going to use this keyify false, and that's going to MapifI, but then not convert into keys, into keywords. There we go. So we do this, and we look at the data. Now our keys are area name as a string, and so that's going to make it a lot easier to work with and actually work. And here I'm just pulling out, here's another way. So if you don't have the CIDR inspector, which is what I'm using here, so this is the CIDR inspector inside CIDR inside of Emacs. If you don't have a nice data browser there, then you can also use, you can also get information, you can pull out the keys. So here I'm just grabbing the first element of the list, which is a map. And I'm just getting the keys from that. So this is just the the headings that are applied to the data when MapifI has converted them to a map. And you can pull out vals as well, so you can see what type of values you're getting. Or you could just do first and just have a look at the whole thing, because obviously if you do just look at the whole thing, then it's got a lot of entries in there as well. So you need something to browse through that. Okay, so now when I want to filter by country or any kind of location, then that's working now. That's working fine. Here we're just using the key, the string key, and we're gonna get the area type. And if the area type is country, then we're going to keep it. And if not, then we discard it as well. So that's kind of what we did before, but it now works. And so now I've just created a helper function for that. And we can do it for countries. Oh, that should be regions. Oops. Cut and paste. There we go. If we look at the CIDR inspector again, so this is all the regions, and if we look at this, we maximize that. There we go. Let me set the size to 24, and it all fits on a page, and it allows you to page through all the data as well. So if you've got a really large data set, then it's really useful. So I'm just doing N and P to move backwards and forwards. So you can see these are all in order as well. So that's quite nice. It's sorted them out by the area name. Interesting. And if we do, if we go through, we can actually see that they're actually starting to. It looks like they might be repeating. So there might be more than one. So there's more than one value for each local authority, because it's doing daily records, which for some views that's going to be fine. For other views that's going to be interesting. We just want the actual total sometimes, but it's quite useful to just have one data set and then just transform like the parts of the data set you want into the information to be used with particular views. But so we've got our data in a format that should be good for using with Vega, and now it comes on to trying to figure out how to actually get a geographical visualization of that. So there are these Geojson data formats out there which give you maps that you can use, and then you can apply data to those maps, and Vega will render that for you. So if you go to, there's quite a lot of different ones as well. So it's actually finding a relevant map that actually works for you as well. And they're basically just a big JSON file. Lots of scary data just boom dumped in. But it's actually fairly straightforward once you know the basic structure. If you just look at the top level, it's saying it's a feature collection, and so that means it's a collection of features. So we've got this feature top level key, and that's basically just a collection of a feature, a collection of multiple features, and each feature has lots of things like data. So this is the Geojson kind of location, and importantly, it's got the Geojson, so like a key for the name of the district, and so these are unique to England. So this is kind of like a location for England, and this is like a local authority district 13, because it was generated in 2013. And this is the name that was used for that district at that time as well. And so you can see all these are local area districts when the feature is a that type of thing. So it's a type of, this is a type of upper tier local area district. So it's got some information that's useful, so that actually the data about the name is useful. We're going to pull that out, and then it's got geometry, and so this you don't really need to worry about. This is just like how to render the particular shapes of that region in a map. So it's quite verbose, but we can ignore that, and we can just focus on the this LAD13 name, and I'm assuming NM means name, and so we can just pull that information out. But then how do we associate that with the cases data that we want? So that was the one that's I wasn't quite sure on at first, but then the answer is actually a lot easier than I thought it would be. And there's lots of different kind of maps you can go and get as well. So I did have to have a look around, see which data maps there are. Some worked better than others, some didn't work at all. So if we go back to the comments, there's a few different ones I tried, and the one that worked was this. Was this one? This is what I'm using. So I just downloaded this as a file and put it into the resources public Geojson thing there. So if I open up the file browser, yeah. So we can use the URL. This is just directly using a JSON value. We can just pull in here. It'll just read the JSON. It'll just pass this JSON to vega-lite for displaying. And the URL is just using a file. Obviously, you can use an actual URL, actual location of this on the web as well if you wanted to. You might want to take a backup just in case somebody decides to change it. And this is just in this resources public. So the URL for a local file is based off the resources public folder. So in that folder, I've got geodata folder, and then the file name there as well. So that's where that goes. I had a bit of a fun trying to figure out where everything should go because they're using different routes. Okay, so we're pulling in this data, this Geojson data, and we're using that as our data structure. So this will just actually render, hopefully it should re-render a map. So if we put that data into this DEF, this UK England local authorities, this should just generate a view just with the map, but with no data on. So if we switch back to our Oz view, there we go. So that's our starting point. And I've just added a few extra things on that, have I? I think so. Yes. So the mark is a Geojson shape. So you could just use, let's see, boom, 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 boom. Let's comment that out. So you could just use the geo shape. Boom. Let's take that out there. Boom. Yep. And this just renders how it is to start with, which is pretty much the same. I think there's, let's just try that again. Oh, maybe I didn't render it. Oh yeah, so you can see that the boundaries are less clear. So what I did was just to make a bit of differentiation, especially because there's quite a few small ones in there. So I've put this like stroke width on here, which just adds a bit more kind of demarcation between the different regions. There. Although it's going to get a little bit confusing down there, so I've kind of experimented with the width and thickness of that stroke line. And you see this is only covering England as well. We're not covering Wales or Scotland or Northern Ireland, but it's a useful starting point, and it works. So the other two things I grabbed weren't quite working as well, so I have to try and figure out what's going on with those. But we got our map, and then when we do a view, we can't really have like two, as far as I know, you can't have two data sources here. We need to combine our cases data with the geo data that we've got and have one data structure that we pass in that has all the information there. So this is what we tried to do here. So we're reading in the Geojson file. So rather than using a URL, we can just read it in using a similar approach that we've done for the other for this other CVS file, except this time we're doing a JSON read and doing a JSON mapper. So we're reading in the file using this IO resource again, which is just the same, and then we're going to do a JSON read instead of a CSV read this time, and we're converting it to a nice Clojure data structure there. So if we do that, and then we can then use that inside our view. So this gives us a structure that's kind of like this map here. So this gives us, if we expect this, then we've got features, which is one of our top level keys. In fact, the top level key. So this is a collection of features, and then they've got properties, and then they've got the geometry, which is all the Geojson stuff. So the most important part of that is things like the properties. So inside each feature, we've got a properties thing, and we've got our local name, which is one of the ones we're going to pull out with, and then a whole list of coordinates, which is a vector, a vector, a vector of vectors. Well, actually, no, it's a vector, a vector of vectors, and each of those vectors has two vectors in, which I guess is x and y positions, because it's a two-dimensional map. So you could actually go in and hack the geometry. Might take a while, but it is possible. But for what we're doing, we don't really need. We can just kind of rely on whoever's created the map that is accurate enough for us. It's not often that pieces of a country fall off, but you never know. And this type is feature. So that's the. So we've got features, which is a collection of type of features. But each feature, so inside here, we don't have a. It'd be nice if we could just put in a cases key with the number of cases for that property. So then we'd, like for Hartlepool, we'd have like the current number of cases in here. So that's something we're aiming for, but we can, even when we've converted the data, the geodata into Clojure, we can still view it with this view, and we should get the same view, so it's not going to look any different. And then, so now it's a Clojure data structure. We can start adding things to it. We can merge in data. We can update that data structure just using normal Clojure code. So we want to pull out the district name, and then we want to update that and pull the same district name out of the cases and put it into the the resulting file, the resulting map that we've got here. So we want to add a cases thing here to the geometry. Boom. And then we can just use that with Vega, and I can just say that when we can pull out Hartlepool as the name and the cases, and then I'll display that on the map using the correct geometry. So it abstracts things very nicely. We're just creating a nice data structure that has the relevant data in. So we just need to feed in this cases data. We can get the name very easily, because we can just basically, this is a nested map, so we can just do like a get in and go properties lad13mm. So here we just, as a test, we're just grabbing the first feature from our overall data structure. So we've got our England lad Geojson file, which is the Java, which is a JSON file that we've pulled it in and converted into Clojure. We get the features, and the first of those features is the first feature, which just happens to be the properties of that, and the name of that is Hartlepool. So that's the first one in the list. So that shows we can pull out, using getIn, we can pull out the name of the local authority. And so then we can just map over. So if we want, so we can take we can map a function over our data set, our original geo data set, that will just basically get the feature name, so local area district name, and then we get the cumulative lab confirmed cases from that, and then that gives us a nice total. That's the basic things. It's not quite what we want to do, because it's a bit more complex than that, because we've got multiple entries of Hartlepool and so on. But this is basically what we're trying to do. So we're basically trying to do an update we're taking the Geojson data file, and then we're going to update the key, which is features. Oh, it's features, isn't it? Features. And then we want a function that will update a specific keys within each feature. So it's going to update it's going to take all the features. So all the features collection. So the collection of individual features is passed to whatever function we write here. And then we're going to just iterate over all those features and update the keys for each feature itself. So this is what we're doing with this update function. We're taking the Geojson data, and we want to update on the features. So the features pulls in the key that is associated with the collection of each individual feature. And then we're going to map over each of those features in turn. So we've got this little anonymous function that basically takes each feature, and then we're going to associate in that feature, just put a new key in there as well. So we're just going to put a new key called cases into each feature, and we're just mapping over the collection of features that we're being given by the update function. And then the bit I've almost got right is we got so getting the local area district name, because we've got this feature, which is the specific feature we're looking at as we iterate through the collection of features. So we can use the key properties to get the map that has a key called lad13mm in it, and then we use that key to pull out the actual value. So this gives us the name of the local authority. So this basically goes in and pulls out, so this is the same as doing this. So it's pulling out that data. And then we're just going to compare that with the area name, just to be able to filter, and then so we can use this as a filter to filter out all the data sets that don't manage the current name. This is a little bit brute force, so because we've got multiple Hartlepools, so part of me wants to actually just go back to the original data and clean it up and just have like a data set that just has the the overall total in. This would make this a little bit simpler. So I might go back and create another view that just has one instance of each local authority, and that's got the latest total in, and then that makes this cases a little bit simpler. But basically we're filtering out all the ones that and returning all the ones that just match the current feature name, the current local authority, and then we get from that the cumulative lab confirmed cases. And if it doesn't find that, I've just put a default on that just generates like a random value, just so I can see that the geo map is being populated. It's also useful to have like a default value, but probably not a random one. So if we do that, so now we've got this new data set, which is the Geojson one, but now we've got it with cases information on there. So we've still got the big file, big data, and if we go into the features, so this is a collection of features, and now we can see that we've got this cases key. So I do have it adding values on here, although I think some of my code isn't quite right, so it's not adding the correct values because these are quite high. So it's not quite pulling out the right information, but we'll come to that in a moment. But it does mean now that we've got a GeoJSON file with all the coordinates, so we can put in here the values, so data values instead of the data URL, and we can take the Clojure data and display that. We've just got a format of using features, so it's going to take each feature and use that as the data set to visualize. And then we've got, and we're using the mark, which is the type of visualization, which is the geo shape. And we're encoding that with field cases. So that's just off each of the cases keys in the features. And we've scaled this just again because we put that random int number. We use the same scale here. So what we got with the view there? Oh, we're nearly coming up to time. Oh, it's taking longer than I thought. Let's have a look. Oops, where are we? So we've got now we've got. Well, it's actually working. It's actually working fairly well. But we can't quite see. We can see there's differences in colors. Different areas have different kind of levels. So the lighter the color, the fewer the cases. But we can't really tell which of the cases have actually what the values are. So it's a little bit limited. We can kind of get a view, but it's nice to kind of have the extra thing so we can hover over a particular area and see what the value is for that. Just adds a bit to the visualization. Oh, one thing I needed to do was convert this into strings. Convert from strings into integers as well. So if you've got numerical data that's actually in strings, then you can just map integer, pass it over it, and it'll convert that into from strings into numbers, and that way it makes it a lot easier to work with if you want to get sort of maximum values. Because one of the problems I think I've got in here is that when I'm doing the cases, I'm actually getting back multiple matches. So I'm actually getting a set of values. So then what I was trying to do is just map over the set of values and just get the maximum value. So in order to do that, then I'll need to convert the strings into numbers to be able to use the apply max. Whereas Vega's is okay using strings as values, as numeric values. But if I want to use some of the Clojure stuff, then sometimes I'll have to convert that into an integer value, which is what I'm doing here. And then, yeah, and then we get here. So now we're getting a much more obvious kind of distinction between different areas. We still can't quite see the values there, so I still want to add a tooltip on the top of here. Let's go back to code. So the other thing, I haven't actually changed anything in this view. Then it's just that the data we're using has been updated. And are we using? Oh, sorry. No, I did change one thing. I did change the scale. So I'm actually using the values that are inside this COVID cases, and just getting the maximum number of cases. So that's one. Oh yeah, that's why I did this max thing initially. So I want to find out what the maximum number is, and so then I can have a relative scale on the side. So when I do, so this scale is going to be relative to what the biggest number is. Unfortunately, these areas of black, they're off the screen because we've got multiple readings for each of these regions, and it's cumulatively they're bigger than the actual maximum. That's why the image is black. So I should actually use daily confirmed cases in no cumulative. Yes, cumulative using the max one, but I'm kind of using cumulative in when I'm creating the data, I think. So I went back and I'm still using cumulative, aren't I? Well, that's fine. So I went back and to try and do the update cases data. Oh, where did I put the tooltip? I'll do the tooltip first and come back to that. Yeah, so I've added a tooltip here, which is just another key on the encoding. And it's so we're just using the location. So it's going to pull out the location name, which, oh yeah, that's something I added to the update function. So the update function, just like cases, but much simpler. I just added this location key as well, which is just pulling out the name of the location. So that puts it at the top level. Just makes it easier to pull that out inside Vega, inside this Vega data. And so we can pull out this field location and with keys, and then when we view this as a tooltip, then it's just going to show the values for the location cases. So let's evaluate that. And so it's really easy to add a little tooltip on there as well. Whee! And so you can see the value of those cases as we go through. And I can see now that yeah, these values are not right. So depending on how many entries there are for each district, you can see that I'm basically summing up those values as well. So I need to just get the maximum rather than summing up all the recordings. So I'm summing up the cumulative recordings rather than the daily recordings. I wonder if I change that. Could it be that simple? You never know. Let's see. Although I think there's something else that's slightly broken as well. Oh, it's a little bit different. Oh, that looks better. It still looks quite high. Yeah, those values are still quite high. So I'm still Not quite getting the, yeah, that's very high. But it is working. I just need to do something with the data a little bit better. Yeah, they're far too high, those values. But that's something to work on for next time. It's 11 o'clock. So I think that's all I'm going to cover today. Let's just check, see if there's anything else. So we've transformed the data into maps using our semantic CSV for the UK Gov data, and then using JSONista to convert the Geojson information into Clojure data structures. And then we've just used an update just to add the UK data to the original Geojson data. And then we can just use that new Geojson data with cases to create our view. And it's just a matter now of playing around with the view and seeing how we can actually get the right information right as well. So I've been looking at some other options in there as well. There's like a max aggregate, but I haven't quite got that working yet. But there's a few other options in Vega to do that. Otherwise, it's going back and transforming the data that we have from the UK data to just give me a simplified view of that. Just give me a simplified view of just the kind of almost like the headline figures for each of the districts. And then that makes it very easy. It makes this update feature a lot simpler because I can just grab the cases data set will be a lot simpler. It's not going to be multiple entries. It's going to be one entry for each region. And that's what they did. If you've looked at the applied sciences if you looked at applied sciences here, then their data, they just have one entry for each Bundesland, each region in Germany or Deutschland. Oops. So I'll try to do this up, and once I've got that all working, I'll add that to the main namespace, which is this COVID-19 dashboard. So again, we've just been working in the design journal. So I'll update this and put in some views. There, I'll move the view to these vega-lite components. I'll put the kind of like the England view, England local area district view in here. And then I'll also update the gov.uk with the transformation, extract and transformation code I've used to get the data in the right shape. Oops. Oh, crumbles. Breakfast time. Oh, messy hair. Well, thank you very much for joining me. I hope you found that useful. Again, if you've got any questions, then feel free to reach out to me via the Practicalli website, which seems to have disappeared. Oh, there it is. There we go. And yeah, and via the Clojure in Slack as well. It's the easiest way, or john@practical.li. And always useful to get your feedback. What works, what's clear, what needs more explanation, and any other things you want me to do as well. That'll be very handy. Okay, well, again, thanks again, and I will see you next week. Thank you. Bye-bye. Very comfy, the key. Oh, no. Oh, 6 likes. Woo! Oh, I didn't end the stream. There we go.